over assignment sheet 3 from unit 10-2, the step voltage regulator. Number 1 says, from the following diagram, answer the questions below. Okay, in the following diagram we have a voltage regulator. It's set in the lower position and on the 13th step. So it's a 13th step reduction in voltage. Okay, each position changes the output by 5/8% or 0.625%. If we change that percent to a decimal, we just move the decimal place over to the left twice. So that's 0.00625. Okay, in question 1A, the circuit voltage is 2612 volts. So 2612 is lowered to the 13th position. So we start out by multiplying the position times 0.00625, and that's going to be equal to 13 times 0.00625, and that's going to give us 0.08125. So if we take the applied voltage of 2612 and multiply that by 0.00625, that tells us that we're going to lower that voltage by 212 volts. So your load voltage then is going to be 2612 minus 212, and that's going to give you 2400 volts on the load. Okay, we can go ahead and do the same thing for number 2. You have 7836 volts lowered to the 13th position. So that will be 7836. Well, let's back up here a little bit. Okay, we have 7836 times 0.08125, and that's going to be 636 volts. So this voltage is going to be lowered by 736. So the load voltage then is 7836 minus 636 volts, and that's going to be 7200 at the load. Okay, finally down here we have 8294 volts, and that's going to be lowered to the 13th position. So it'll be 8294 times 0.08125, and that's going to be 673 volts. So your load voltage then is going to be 8294 minus 673, and that's 7621 volts. Okay, moving on to number 2 in assignment sheet 3. We're given a number of different situations here, and in this first one, they want to know what the output voltage is for the following situations. 2400 volt circuit, third step raise. So we've got to go ahead and back up here and say the third step means it's going to change the voltage by 3 times 0.00625, and that's equal to 0.01875 increase. So you'll take your the load voltage then is going to be 2400 plus 2400 times 0.01875, and that's equal to 2400 plus 45, or 2445 volts. In B, we're going to lower the voltage to the 7th position. So we're going to lower it by 7 times 0.00625, and that's equal to 0.04375 lower. So the voltage of the load then is equal to 7200, and it's lowering now, so we're going to subtract 7200 times 0.04375, and that equals then 7200 minus 315, for a grand total then of 6885 volts. Okay, C is in the neutral position. So in the neutral position, we're going to change the voltage by 0 times 0.00625, which is 0. There's no change in the voltage, so the voltage of the load is 14,400 volts. Okay, in D, we've got a fourth step rise of 7620, so it's going to be 4 times 0.00625, which is 0.025. So we're going to raise the voltage. VL is going to be 7620 plus, because we're increasing it, 0.025 times 7620, which is 7620 plus 190, for a grand total of 7,810 volts. In E, we're going to raise 4,800 9 steps, so it's 9 times 0.00625, or 0.05625. So the voltage of the load is going to be 4,800 plus 0.05625 times 4,800, and that's going to be 4,800 plus, let's see here, 270 volts, for a grand total of then 5,070 volts. Okay, and finally, F, 2400 volt circuit, fifth step raise. So it's 5 times 0.00625, which is equal to 0.03125. So the load voltage is 2400 plus 0.03125 times 2400, and that's equal to 2400 plus 75, for a grand total of 2475 volts.